Good evening. Good evening, ladies and gentlemen.
The microphone working.
The microphone is on. Thanks very much for coming on a Monday night to celebrate the UK's computing heritage. It's fantastic to see so many of you here and so many faces that we recognise. So as you know, the UK has a fabulous and long computing heritage. But it's not something that has necessarily reached a wider audience in recent years. It's kind of sort of hidden secret, I think, very often. And this is something that we at Google have spent some time quietly trying to encourage more knowledge about the UK's computing heritage over the last 2 or 3 years. So we're delighted to have you here tonight to meet some of the pioneers of the internet.
Thank you for not saying dinosaurs.
To look at some films that we've been producing over the last couple of years, and to hear some talks. So the evening is in a couple of parts. We're going to talk here to the four musketeers of the internet in a moment. Then we'll have a little bit of a break, an opportunity to mingle some more, eat some sweets and popcorn. And then we're going to come back with a couple of films, a couple of talks, and a Q&A with Vint at the end of the evening. Right, so I'm going to sit down and we'll kick off. So let me introduce you to four of the great pioneers of the internet. Starting on the extreme left there, Peter Wilkinson and Roger Scantlebury, who were at NPL back in the 1960s and 70s. And really helped develop, I suppose, what you could call the first internet-like thing in the UK and indeed in the world. And certainly the term packet switching developed or coined for the first time at NPL in the 60s. Vint Cerf, now obviously at Google, Chief Internet Evangelist at Google and Google Glass wearer.
That would be me.
Who was at ARPANET at Stanford, again back in the 60s and 70s.
Actually, it was UCLA, it was ARPANET. Internet is Stanford.
Oh, sorry.
You know how the difference between Stanford and UCLA, I mean,
we'll get to that.
Is there a difference?
We'll come to that.
And DARPA as well.
Yes, also true.
And Peter Kirstein, University of London, and the first person to bring the ARPANET node to University of London in the early 1970s. I hope I've made that introduction reasonably accurately. So really, my role in this is not to intervene too much, but really to wind them up and let them go. And having had a little bit of a conversation with them earlier, I don't think that's going to be too much of a problem. So, Roger, I was going to kick off with you.
Well, if you don't mind, I'd like to grab control
you go ahead.
this.
Yeah, go ahead.
He always does.
Well, you know, it's a habit, sure habit. So Peter and Roger were both at the National Physical Laboratory, and the then superintendent of the Computer Science Division was Donald Davies, who was instrumental in inventing the term packet. He worked with a linguist to do that. But what was more important is he initiated a project there to build what was intended to be a national scale packet switch network. And so the documentation, the design work, and everything else, all of which took place during the mid-1960s to sort of the late 60s and early 70s, was intended to be a project not at all unlike the ARPANET project, which began in 1968. So, I mean, they were essentially contemporary projects, each of them intended to be a small-scale network to test the idea of doing store and forward packet switching. So Roger and Peter were very, very much a part of that early design work. And in fact, I'll let you guys tell part of that story, but Roger was the first person to bring some of these ideas from the UK to the US in 1967 at a conference in Gatlinburg, Tennessee, where he met with Larry Roberts, who was the primary overall manager of the ARPANET project for the Defense Department. So can you give us a sense for how this thing actually got started? I mean, in fact, what the hell was NPL doing in communications when that wasn't your charter?
Well, that is true, and of course we got rapped over the knuckles for doing it, but hey, what the hell, you know. Perhaps it would be a good idea to put it in context. Donald Davis, as you said, was the superintendent of Computer Science Division, and Computer Science Division had a long history in computing, going back, in fact, to Alan Turing, who came to NPL in 1946, I think.
Wow.
And in fact, I've got a picture of the Colossus machine. That's Alan Turing. As I say, he was responsible, well, not responsible solely, but he was one of the prime movers and shakers in the Bletchley Park machine, the Colossus machine.
Should we pause for a moment? How many people have had an opportunity to go to the Computer History Museum in Bletchley Park? A few? Quite a few. Good. Okay.
So you guys will have seen
yes,
this,
and you're familiar
this
with
machine actually still operating, which is a remarkable feat. As I say, Turing came to NPL in '46 to start work on a computing project. They were going to build a thing called the ACE computer. After about a year, he got fed up with the prevarications of the civil service who operated the National Physical Laboratory, and decided to go and work with Max Newman at Manchester on the Manchester Mark I. Fortunately for us, he left behind a dedicated team, one of whom was Donald Davis, who was his sort of immediate aide, and some others like Ted Newman and the mathematician Jim Wilkinson.
Not me.
No relation, no relation, and several other noteworthy people. And they built a pilot model of the ACE. They decided to do a cut-down version first, and this is a picture of the pilot model ACE, which I think is actually in the Science Museum now. I think the Science Museum have got it somewhere. And
but not functional, is that correct?
I don't think it's functional, is it?
No, it's in the Alan Turing exhibition.
Oh, right.
Okay.
Okay. That machine first ran serious programs in 1950. And there's a bit more to it than that actually shown in that photograph. There was some, the short-term memory, the RAM, was mercury delay lines, sonic mercury delay lines.
You know, if somebody had walked into my office and told me they were going to build a memory system based on sonic transmission in a mercury delay line, I would have thrown them out of the office.
Yeah, absolutely.
You know, this
absolutely.
is nuts. How could that possibly
Strangely
work?
enough, it worked. They were kept in a special heat-constrained room so that because the mercury would change length with temperature. And then we added some drums to the machine. For my sins, I joined this team in 1955, would you believe, and worked on a little bit on this machine, but on its commercial successor, which was the Deuce computer. I think we have a picture of the Deuce computer.
That's not it.
There we are. Yeah, that was it. The Deuce computer. And here we see hardware and software.
This is
the
Deuce
software
because
being
the first
actually-
one was Ace and the second
One was Deuce, yes.
-2.
Yes, yeah. Yeah, so the software is in the punch card box here, just in case misunderstandings here. That was a commercial machine. I think there were about 30 odd of those machines actually sold in the UK. So it was quite a successful machine. Thermionic tubes, of course. And so...
So Ace was tubes also?
ACE was tubes.
ACE was tubes
yeah,
also.
And the follow-on to that, the thing that was called the full-scale ACE was also tubes.
Well, they were tubes for another 10 years.
Yes,
the
because
first, the 1794 and that era was the first one which was semiconducting.
Mm-hmm.
But that's the background of computing in NPL. And then in the early 1960s, Donald Davis had become aware that the next big thing was going to be the communications between computers, and had fairly quickly come to the conclusion that the telephone network was not the right vehicle for connecting computers together. We had a meeting with the Post Office research people in Dollis Hill, I seem to remember, in early 1960s, I'm sorry. And they, the chairman was an erstwhile analog switched telephone network man. He had been chairman of the CCITT. And he just gently pointed out to us that digital telephony was really nowhere. There were millions of telephone handsets and about 2,000 modems in existence. So clearly, it wasn't going to go anywhere, and we should stop messing about and
Stop wasting.
stop wasting time and,
Yes.
and go away and do some thermometers or something, or whatever NPL was supposed to do. So Donald, of course, once he became superintendent, had a budget and was able to, I think it's called Black Ops.
Well, some of us in the U.S., we call these skunk works.
Skunk work,
Because
and
no
yeah,
one wants to
that's-
go there because it smells bad. And they stay away and you get some work done.
And that's where we started the work on the NPL proposal for a national network, quite rightly so, said so. And that work started in '65, and we published a report in 1967, which I had the privilege of taking to Gatlinburg, where I met Larry Roberts for the first time. And the rest, as they say, is history.
So,
Oh, history or disagreed history. As one who tried to write a paper on that
Not the
history
end of the story.
and then had to try to make peace, I'm not sure it's all history.
well, one question I have for Mr. Wilkinson is, what was your role, in fact, for the two of you, what was your role in the project itself, the network project?
I was a sort of software guy.
You were the software guy, okay.
So I'd been a part of the team working on the feasibility study, and came to the point where we decided we were going to build our own local area network within the NPL campus. So the finger pointed at me, Wilkinson, you'll write the NPL network software, won't you?
Thank you.
So I said, fine, okay, yes, because I expected to be asked, but I really didn't have a clue where I was going to start.
So what computer did you use to build the packet switch
Well,
at NPL?
We chose the same computer that it happened that the ARPA people had chosen, the DDP 516, which
This is
doesn't tell you a lot, does it really?
this is a complete coincidence, right? Because the ARPANET used the DDP 516 machines from Honeywell also, instead of the Plessey machine. Or
Well,
what was it about Plessey?
We had
that-
originally chosen a machine, the Plessey XL12 machine, to do this role. And the reason we chose it was because it had a digital direct memory access system, and you could attach sort of 500 devices to the DMA channel, which meant you could input and output to devices without running through the processor. So the processor merely had to do buffer allocation and that sort of stuff.
And it also had a good interrupt system, which was pretty crucial, I think. But
And
it turned out that the DDP 516 had a similar, sort of almost as good architecture, and the team, the Honeywell team, were extremely cooperative in doing what we wanted to, bring it up to our sort of requirements.
yes, they actually built, we slipped them the idea of this DMA channel, and they built it for us. So within about, I think it was less than a year, about 9 months from the time we learned that we weren't allowed to buy the XL12 because somebody in the ministry had decided that Plessey didn't make computers. They were just told, sorry, you don't make computers. They went, oh, okay. And so we got the DDP 516 team to build the direct memory input-output. And if you could go back to to that picture, on this side, you'll see all the digital equipment, the input-output mechanism and the multiplexers and the line drivers that fanned out all over the lab. National Physical Laboratory covered an area of 78 acres, and there were, ultimately we had several hundred terminals and computers attached to the network, and they were all run through this digital network. And in fact, it was like a modern local area network, and it ran at one megabit per second.
It was one node network, although the design was intended for multiple nodes.
Well, the idea was that this would be a packet switch, and it indeed was a packet switch. We weren't allowed to build a wide area network because we were forbidden. So we just built the local area network because they couldn't stop us.
So what's interesting is they used a T1 speed system, a megabit-based system, in order to connect the devices to this switch and would have connected the switches to each other. Peter?
Now, in fact, when I comment on that particularly, there were some other very significant differences in the thinking behind the NPL network and the thinking behind the ARPANET. One of the problems which ARPA had at that time was that they were not in the communications business. They had to connect computers together. And Steve Lukasik, as director of DARPA, spent many, many anxious months trying to prepare papers to prove he wasn't in communications. Because if it was, the Defense Communications Agency would have taken over the project. All he was doing was connecting computers. By contrast, NPL started from the other, at least Donald started, from the other side. He said, look, whatever the British might be saying about analog switching, and one must remember that in around about 61, 62, one had the first digital telephone switches. They didn't work very well, one problem, but much more important, because of something which may sound familiar to you, because of problems with unemployment. One decided to stay in analog switches for another 10 years because the analog switches were built in Liverpool and Nottingham, and shelve digital switches. Donald, however, said, look, the T1, depending where you are, whether it was 2.048 or it was 2.048 as far as the British were concerned.
That's E1. Yeah.
That is the future of communications, whatever the British Post Office and DTI might say. Therefore, we should build this lowest level of switching into the same communication infrastructure. That was a thinking which actually didn't occur in the US till quite a bit decades later.
That's true.
Even though I'm, of course, a great believer in what you were doing, of course.
So this actually is a very interesting observation, because the T1 notion arose in the telecommunications world more or less in the same period of time, in the early 1960s. And yet, by the time DARPA was doing the ARPANET project, it took convincing by Roger at this meeting in Gatlinburg to recommend that the ARPANET project, which was intended to be a wide area 4-node network initially and then would grow if it worked, they were looking at 2.4 kilobit circuits using relatively low-speed modems. At the time, 2.4 kilobits was thought to be
That was reckoned to be quite
moderate speed.
Quite moderate. Yeah.
And Roger quite correctly pointed out, partly on behalf of Donald Davies, that much higher speed would reduce the delay for forwarding the packets through a store and forward network, and convinced Larry to go to 50 kilobits a second. But what puzzles me, and I hadn't thought about it till now, is that T1 was actually functionally inside the network, but it would not occur to the telephone network people to externalize access to the T1. That was their trunk speed. What the hell do you think you're doing connecting your peripheral device at our trunk speeds? You'd overwhelm the trunks in no time at all. So we ended up with bonding 12 analog voice channels together to make 50 kilobits per second with a Bell 303A modem that was half the size of a refrigerator.
That's right. Yes.
But we chose the same DDP 516 computers, completely independent of each other, and built the ARPANET in 1968.
You are aware that the guys from Bolt, Baranek and Newman actually came over to NPL in, I think, 68 for a kind of a... We had exactly the same problems. You know, we weren't allowed by the record carriers to do wide area networks. We solved it one way. The ARPA people called it something else and solved it another way. But a lot of that thinking was discussed
That's
at
interesting.
those meetings.
I didn't know that.
Now,
BB&N
T1 carrier, of course, was invented as a way of multiplexing lots of speech channels over a pair of wires, because they were running out of duct space in the ground. And so to take a whole T1 carrier when you can actually multiplex 24 or 32 speech channels, as you say, what are you doing?
Yeah, you can't do that.
You can't do that.
Right.
Well, actually you can.
So you were running 25 times faster than we were in the backbone. But our problem was to build a wide area network. You had to get channels that would go over a wide area, and they refused to offer us anything less than, or anything more than 50 kilobits a second. So now Peter Kirstein in 1973 receives the first ARPANET node in the UK, connected at the time, to the Norwegian Defence Research Establishment by way of a 9.6 kilobit landline.
Well, I think I'll go back a little bit further on history. First of all, the one which was supposed to go onto ARPANET was the NPL.
Okay.
What actually had happened was that DARPA, which I think at that stage it was ARPA, the Advanced Research Projects Agency,
right.
was very advanced technically, but completely and absolutely naive at what communications, international communications, was about.
Unsophisticated would be the best way of saying it,
And-
yes. I mean, they're a bunch of geeks, right? They didn't know anything about telecom policy.
And any of you who have any idea of geography would understand why one might have 3 large seismic arrays in Norway, Montana, and Alaska. It's purely arbitrary, of course, where they were politically placed.
Pointing
But
somewhat, yes,
they did
yeah.
happen to have 3 seismic arrays.
Hoping to remember, this is in the days of the Limited Test Ban Treaty, and the question was, have the Russians exceeded the limits of the Test Ban Treaty? How could we tell? They wouldn't let us co-locate with their tests, so we had to detect what they had done using a seismic array system, and Norway was a convenient location.
And there was a treaty at very high level organized between Parliament and Congress on collaboration on this seismic array business. Well, although on the whole we regard things for packet switching, as far as ARPA was concerned, one of the very, very important uses of this peculiar thing they were building was actually to connect things like these seismic arrays back, and that was computer connection after all, back into some big data stores which they were building in Washington. So somewhere around 1969, 1970, when ARPANET was just starting, Larry Roberts had the mission of putting this seismic array onto the ARPANET.
Ah, okay.
And put it in with a 2.4 kilobit line. Well, by that time, modems, they were very expensive, but you could just about go up to 9.6 kilobits.
Yes. But you really squeeze.
Shocking.
These things were possible. And so, obviously, in those days, there were almost no Earth stations. One of the very few places which had an Earth station was Goonhilly. And so the only way you could connect a Norwegian Earth station was to take a satellite connection to Goonhilly, go by landline to London, go by undersea cable to Norway, and that way you put the seismic array on. Well, I did start by saying that Larry was a little simple-minded in some things. He thought, well, you just cut the line. It's already going to London. Just have it go to the NPL, connect them onto the ARPANET 2, and then go on. But there were 2 or 3 problems. There were some minor problems about communications, but I'll forget those because I had to solve those too. What was rather more serious was that 5 years earlier, Mon Général, General de Gaulle, had said non, to the British joining the common market. This may sound familiar too, but that's beside the point. He had said no. And so at this stage, when it was suggested that the NPL go onto the ARPANET at the highest, and I mean the highest level of government, the British government said non or no because America was bad, USA was bad, Europe was good. Therefore,
We've come full circle, haven't we?
well, I didn't like to say that. Well, you know, our papers say the same sort of thing. But therefore, Donald was not allowed to connect it on. Well, I was definitely second best, but I had a certain awareness of the US in various things at the time. So he gave me the largest amount that he was able to do from his own budget, because as soon as he went outside his own budget, there'd be minor political problems, which would become major political problems, which would become another no. And so he offered me £5,000 to connect.
That was when £5,000
Pounds
was actually worth something.
£5,000,
right?
yes.
Yeah,
You could buy a whole computer for that. I mean,
Yeah, right.
nearly.
Well, you couldn't, but no, computers were expensive too.
Yes.
So he offered me £5,000. And I would put in a proposal to the Science Research Council on this, that this offer from Larry Roberts. So that went in, but nobody in the government believed this kind offer from ARPA. And the next that happened was a telegram went. This was the days when telegrams still existed. A telegram went from the director of the Research Council to the director of DARPA requesting confirmation of this offer. This was the first the director of DARPA had heard of an international connection to a rather sensitive, not classified, but sensitive project inside, funded by ARPA.
This is to make it even worse. You want to connect a college academic thing to our seismic array in Norway? Are you crazy?
It was worse than that. I also wanted to find information about how a defense line, LO51, was connected to the US from Norway through Britain. And those days, academics were not allowed to know anything about defense lines.
Well, didn't we run into a problem with the fact that you were a civilian university and ARPA was a US defense activity and the seismic array was a defense activity, and how can you connect a military thing to a civilian thing?
Oh, it got a lot worse than that. If you look at this picture behind you, eventually when we were, I can't remember how we actually worked the Oracle. I think you had a great deal to do with this, Peter, but we actually managed to connect the NPL network through UCL to the ARPA network. And at the same time, of course, there was a thing called the European Informatics Network. And NPL was the UK node on the European Informatics Network, which was also connected to the French research network, the CCLAB network. And all of a sudden, the post office and Cable and Wireless and AT&T became suddenly extremely scared that there was a big-scale international network. And all hell was let loose. We had to sign disclaimers this long about what we were and were not allowed to do through this connection.
So I want to take advantage of this part of the discussion to point out to you that if you think that computer networking is mostly about technology, you're wrong.
Oh.
It's mostly about trying to solve bureaucratic problems and getting people to cooperate with each other. The policy problems are harder than the technical ones.
Well,
the
on
politics.
This, one of the fellows who's in charge at that stage of post office policy was somebody who you may remember, George Orchard.
Oh, indeed.
And I was having lunch with him one time. And of course, in those days, the post office had a complete monopoly on message switching. And if you think message switching is something electronic, you're wrong. If you do a semaphore across a public right-of-way, that was probably message switching. And
optical. Right.
Yeah.
And things like emails had sort of been heard of and were clearly completely illegal. So I put a problem. It was illegal if you were connected to the telephone network. So I put a little problem to George. I said, George, I have a computer. And my computer has files. And for 59 minutes, for 50 minutes, I said first, in each hour, it's connected to the telephone network. And during that time, people put their data into my files. Then I disconnect the telephone network and do a little bit of sorting of the files. And then I connect onto the telephone network. Where have I done something wrong? And when you had a little difficulty with that, well, what happens if I change it to 59 and 1 minute, or 59 minutes and 59 seconds and 1 second? Where was the illegality? And I'm afraid his answer is, oh, Peter, I wish you hadn't asked me that question.
So what's your, one thing I would like to suggest now, but I don't know how your timing is.
I think we've got, what, about 5 minutes or so? 10 minutes?
Oh, 10 minutes, okay. So another thing, if we could have that little diagram back again for a moment. This doesn't show the NDRE component, which would have gone up from UCL.
Wasn't significant.
Sorry?
It was not significant because
It was
there
also part of a military
Well, what do you
system
mean
which
by
we
it
weren't
wasn't
allowed to
And
show
what,
on
it was,
any diagram.
what I mean by that, there was a very, very important difference between what the Norwegians did
Yes.
and what the British were doing. The Norwegian, nothing, no part of NDRE, Norwegian Defence Register, was attached, only the seismic array. There was no onward links.
Okay.
There was no onward links from the large computer in Keller. It was attached by itself, and there were no links beyond it. By contrast, from the beginning, the British, we had several networks. And if I may just say one more thing about that, one of the biggest networks on it at the time was the high energy physics network.
Yes, that's right.
And that included, of course, a link onto CERN. And so, of course, I got a question from the beginning from CERN. I had to ask permission for anybody who was on it. Could they link in to the ARPANET? So, of course, I had to ask my committee, which included British Post Office, could they? And the answer was, of course, no. But then they went on to say, but how are you preventing it? So I sent back a long answer. There are the following 6 methods in which they could get on. The following 5 I can prevent in the following way. For the 6th, I could put up a notice. If you do A, B, C, D, E, and E, you would get onto the ARPANET, but that's illegal. Shall I put up that notice? The answer was, no, I shouldn't. So you can see we weren't always popular. The attitude, actually, at the post office of this was, we were completely harmless. So let us do what we liked and watch us. And unlike these dangerous people, like the National Physical Laboratory, who would, of course, move the country, we would do absolutely nothing which was of any risk to anybody.
So now I think I'd like to pick up the trace here in a couple of ways. First of all, when the first node of the ARPANET was installed at your facility at University College London.
By the way, the first European, not just not just
First node, European node. Right? The first node of the ARPANET was installed at UCLA, in fact, in 1969. But it's 1973, and this node is connected. I think the way it worked was there was a satellite link that went from the east coast of the U.S. internal to the ARPANET, dropping down to an IMP at Norsar in Norway, at Keller. And then a landline from there went to UCL. But we were interested in experimenting with packet satellite in addition to dedicated landline packet switching. So not long thereafter, a packet satellite effort was put into operation using Intelsat 4A over the Atlantic. And it linked the eastern coast of the US with the west coast of Europe. And the idea was to have multiple nodes in the packet satellite system sharing a common satellite channel. It was like an Ethernet in the sky. It had a bandwidth of 64 kilobits a second. So these guys were still blasting along at 1.5 megabits or 2 megabits, and we're still farting along at our little tens of kilobits a second. Eventually, I think we doubled that to 128 kilobits. But the concept was actually pretty interesting because these multiple nodes would share a common satellite channel. It was a multi-destination half-duplex system. And I remember when we ordered, we put out a bid for a multi-destination half-duplex satellite system. And we got back a number of bids, and one from Western Union International read, Dear DARPA, we are delighted to provide you with a multi-destination half-duplex system. By the way, what is it? So we designed and built, under DARPA sponsorship, this dynamic packet satellite system. And eventually, Peter's system was cut off from the internal ARPANET and forced to operate solely over the packet satellite network. In the meantime, in the United States, we were experimenting with mobile packet radio, which is what you carry around in your pockets these days. At the time, it required a cubic foot packet radio system that cost $50,000 per radio. They were operating at 100 to 400 kilobits a second in the 1710 to 1850 radio band, and they were using in that system spread spectrum CDMA. Now this is in the early 1970s, so it's a very, very advanced system for its time. But the part I wanted to get to is that we've got these 3 networks now, plus the ones that you see here, all interconnected over the satellite link and the packet radio system and the ARPANET. Peter's job at UCL was to implement the internet protocols. So he was, his team was part of the first 3 groups that implemented TCP/IP starting in 1975. The other one was at Bolt, Beranek, and Newman, and the third one was at my lab at Stanford University. So we were doing tests at the blinding speed of 3 packets per second over this multi-network system. We were also experimenting with packet voice and with packet video. Video a little bit later in the late 70s, voice in the mid-1970s. And this is the part that I wanted to take advantage of, because we were testing packet voice, and with a 50 kilobit backbone in the ARPANET, you couldn't put a 64 kilobit voice channel through there very well. So we used linear predictive code with 10 parameters as a way of compressing the speech from 64 kilobits down to 1800 bits per second. Now, what you do is you send the 10 parameters that represent the diameter of a stacked array of cylinders that are changing as the voice is speaking, and then you excite that with a formant frequency, and you just send those 11 things over to the other side, and they undo that compression and produce sound. Well, you lose a certain amount of quality when you go from 64 kilobits to 1800 bits per second. And the way it sounded when it came out the other end was like a drunken Norwegian. So I'm at DARPA by this time, and it's now time to demonstrate the packet voice system to the guys at DCA, the Defense Communications Agency, who are, you know, all about circuit switching and everything. So I wondered, how was I going to do this? And I remember thinking, well, wait a minute, the Norwegian Defense Research Establishment was part of the test. So we got Ingvar Lund to be the speaker. First, we had him speak through the ordinary switch voice system called Autobahn. Then we had him speak through our packet voice system, and it sounded exactly the same. So we didn't tell the generals that everybody would sound this way if they went through this system. So these guys, NPL, UCL, and these personally and their colleagues were very much involved in the earliest stages of both packet switching and international networking and interneting in the mid-1970s. And that story is not very widely appreciated here in the UK.
Do you remember there was a paper that you, Alex Mackenzie from Bolt, Beranek,
Yes.
and Newman, Ube Zimmerman from the C-Cloud network,
Right.
and I was the
Yes.
fourth author,
Yes.
and it was an inter-network protocol. It was a proposal we were trying to show that something that was TCP/IP eventually was something that you would use between the systems at the end of this conglomeration of networks, none of which was the same inside.
Correct.
None of which
Yes,
had the same
yes.
interface, but which could be connected together.
This
And you put it together
interoperability
at the-
was,
yeah.
was everything. And C-Cloud, I'm glad that we have this up here as well, because the French had their network, which is, they had Sigal was the packet switch net, and C-Cloud was the larger scale system with the host computers in it. What's important, I think, is that the Internet project was informed very much by its interactions with people outside the United States. So, you know, when you keep hearing that the Internet was an American invention and everything else, that's not exactly correct, because Bob Kahn and I spent a lot of time with our colleagues here and on the continent exploring this stuff. And I'm just getting the shut up now signal, so I'll shut up now.
So we've got up to the mid-1970s, but I'm afraid we're going to have to stop it there. But thank you very much indeed, gentlemen. I mean, we had the Rolling Stones at the weekend, and that was great. But I think actually this was the gig to be at tonight, and I think our gentlemen are doing rather better than the Rolling Stones in terms of remembering it all and keeping it fresh.
So I've got it written on the back of my hand.
We've run a tiny little bit over. What I suggest is that we give our panelists a big round of applause. Then